Hi, good morning, everyone. As always, thank you for attending our webinar series. If this is your first time, we welcome you. And if you're a returning participant, as always, thank you for your time. So we'll get into it here in a moment. And as you can see by the title, today we're talking about designing secure event-driven architectures in the cloud. And this is a continuation of a series we've been doing, really focusing a lot of automation orchestration. So if this topic is of interest, I suggest going to the website and you can see recorded versions of past webinars. So with that, Jose, if you don't mind, we'll get started. So today's goals, we want to provide inside information that is hopefully new and relevant to you. And I think you'll see that in Jose's content. And on number 3, really the biggest goal that I think I have is hopefully demonstrating our ability to partner with you and allow you to take advantage of our resources, whether that might be a consulting engagement, planning engagement, or deployment professional services. Just want to demonstrate our ability to provide all the way from content generation and education today through implementation. All set, Jose? So I am Joe Paquette, Business Director in the Northeast, and soon I'll introduce Jose in a few slides. Again, we'll talk about event-driven architectures. We'll talk about concepts and practices and use cases. And for Q&A, if we have time, we'll do that at the end, but I'll also say that in your chat window, you can submit a question. If we don't get to that during the presentation, it is recorded and it will absolutely reach out to you after the event. So today we asked folks before the webinar to answer these questions, and I always find this interesting because it sort of gives you an idea based on your environment, based with your peers. So do you feel that your current security event response is as timely as possible? So 40% saying no, they're not comfortable with that today. Do you think that leveraging secure event-driven architectures could improve your security response? Half saying yes. Interestingly enough, there's only half saying yes, but 90% of you are suggesting that you have some plans in the near future to deploy secure event-driven architectures. And certainly if it is 90%, I would say hopefully a lot of folks that will talk to Jose after the fact. How's that, Jose? So quickly before we get into the content, if you move forward, Jose, we'll just give a brief background of New Era for those that are new. Jose, do you mind? There you go. So 70 offices worldwide and 4,000 employees across the organization. And what we like to say about that is we certainly have a global reach. We have the highest level of partnerships with our manufacturer partners, but we do all that with a local touch. So for those that are working with long-standing organizations and resources, I think you know already, you're still working with those same folks. Now we just have the backing of this organization behind us. Jose, if you scroll to the next slide, we'll see those solutions broken out a little bit. Today, we'll be focusing on the security practice. But if you go left to right, you'll see everything from managed services to collaboration, networking. Our SecureBlu services are managed cloud services, everything from unified communication to contact center. And down left, you'll see the pro services, sort of what I talked about in the beginning a little bit about how to engage with someone like Jose moving forward. The real net of this slide is just know that technology in your organization, we can probably help you. So today we're focusing on the security group. SecureBlu is that organization. Our security organization is broken into 3 pillars. First one is advisory. Think of that as engagements, pro services engagements, and I'll show you some detail in a moment. Second pillar is our managed security infrastructure. traditional managed services, taking away those responsibilities, augmenting your staff. And lastly, our managed detection and response organization, providing MDR services. And again, I'll go through that in a moment. So our advisory services, here's a listing of some of those offerings within that pillar. I would say right now, some easy ones would be point-in-time engagements like penetration testing, vulnerability assessments. vCISO has been really, really popular with our clients, providing those virtual CIO services to customers, agnostic, regular structured planning with clients. So this is the advisory practice. Next practice would be the managed security infrastructure I mentioned. Pretty standard stuff, I think, for organizations. Firewall management as an example, the ability for us to maintain, patch, resolve issues associated with your firewalls. If you have a lot of devices deployed, it can be challenging sometimes to keep those current, to maintain those standards and policies. So we can certainly help there. Endpoint detection, EDR products, another one that has been really popular with clients. And then lastly, Jose, if you don't mind moving ahead, is our MDR practice. I'll just take a moment to talk about this. Our practice is very mature and strong and built upon some of the concepts I mentioned in the beginning. So orchestration, automation. We have the ability to ingest feeds from premise infrastructure, IoT SCADA, cloud infrastructure. So we can take all of that information, do the correlation of all those data points. Again, there's a lot of automation associated with that to really drive down the time to respond. And then our team has 24/7 eyes on glass there to support your organization. MDR, again, a very strong offering from the organization, and would love to chat with anyone at some point if there's interest. With that, Jose, I want to turn it over to you. I'm very, very excited for your content today. Again, I'm Joe Paquette, Director of Business Development in the Northeast. And Jose, I will turn it over to you.
Thank you, Joe. All right. So hello, everyone. Welcome to today's session about secure event-driven architectures. My name is Jose Seara, and I am a cloud security solution architect here at New Era. So EDAs are, or event-driven architectures, isn't it a new technology concept? However, it has become more relevant and more popular as companies are going through digital transformation and cloud migration. Thus, event-driven architectures leverage decoupled or distributed services, microservices, which are widely used in modern applications and automated solutions. If your organizations want to adapt to future business demand more quickly, you should consider event-driven technologies. Event-driven architectures can power everything from a simple event notification, like, for example, sending an alert when your endpoint detection and response system detect a malicious activity, to something more complex, such as engaging real-time machine learning or user behavior analytics models, which could be used to further detect attacks and suspicious activities. In the years to come, the ability to think in events and build applications around them will become more important than ever. Apart from business improvement that go along with being faster, making better use of data, and designing more intuitive user experience, there is also information protection benefit by having the notion of event-driven built into the core of your enterprise security system. So rapid adaptive organizations will take full advantage of these innovations to build better and more secure systems. Here are some facts about the stage of modern technology. These are things that you probably have heard before, where the state people saying the cloud has changed how we look at security. Definitely, we're extending our perimeters outside our traditional network. Automation is the main key driver to cloud adoption. This is definitely true if you want to adapt to modern business and rapidly deploy solutions. And microservices are becoming the norm as we start using more container solutions, serverless solutions. Uh, this has been kind of like fired up the whole movement. So for today's presentation, we're talking about event-driven technologies. And event-driven technologies basically are composed of four main components. A producer, which is something that produces an event. The event itself, a platform that actually stream, analyze, and organize the information. And the consumer, which is the end user or the end system that actually consume that information and take actions against those events. So knowing that, let's explore some basic concept about event-driven architecture, right? So what is an event-driven architecture? Event-driven architecture is as simple as a software model for application design. We use events to trigger and communicate between decoupled microservices, which are commonly used to build modern applications or solutions. Moreover, event-driven apps can be created in any programming language because event-driven is a software design approach and not a coding language. So very important to understand that. So then it takes us to the next question. Well, what is an event? What exactly is an event? So events are simple record of activity. Events simple are things that happen within a software system. Each event should trigger one or more actions or processing response. An event contains information about the action that it triggered, the intended consumer, and its state. This data goes to a specific consumers who respond by executing the necessary task. Event can be things such as user-generated events, for example, like clicking on your favorite button on your Spotify application, for example, or a system-generated event where, for example, a series of program databases, maintenance activities, or events can also be produced or delivered by external sources like an IoT sensor, for example. How does event-driven architecture work? Event-driven architecture has, like I said before in the previous slide, has some main components. The event producer, the router, broker, or streaming platform. It depends. The terminology varies depending on the technologies. And the consumer, an event consumer. A producer publish an event to the router or broker, which at the same time filter and pushes the event to the consumer, and the consumer basically capture that information and process the event. That's in a nutshell how it's work. Benefit of event-driven architectures are many. Event-driven architectures are ideal for improving agility and moving quickly. This is especially important for example, rapid incident response. Services are interoperable. They can scale or fail independently. This is the concept of decoupled systems, and basically these allow high tolerance systems, which are very needed in security operations. It could increase application agility by leveraging the router broker to automatically filter and push events to consumers. This This basically can streamline alert fatigue. It can reduce costs because event-driven architectures are push-based, so everything happens on demand. So you just pay for the services that are used, and in the case of event-driven, you basically pay for those seconds where your application or your code is running. It also allows you or have the ability to react to real-time information, and this can enhance your enterprise security. Next, so as any other system, so we have to follow some best practices to secure event-driven architecture. And as any other, like I say, as any other system, security must be considered or should be your main consideration when you develop any architecture. While this might seem an overwhelming task, securing microservices come down to implementing a series of best practices that make security an integral component of the software development lifecycle. Security is a continuous function, and applying basic security measures will ensure the integrity of your platform or system. And as data is transmitted during this process, you should have extra considerations, right? And some of these are very basic to any architecture, but they are indeed needed. This is basically the concept of layer security, where you actually expecting to have some type of safety net in case one of your security control fail. You have a backup, right? So when we talk about incident and access management, or IAM, we look at things like authorization and authentication. Identity and access management governs user access via authentication and authorization, where authentications verify a user identity, and when this is authenticated, the verified user might use any of the resources where they are being authorized to have access, right? You also look at things like security, securing sensitive data with encryption, and ensure encryption mechanisms to secure messages either by encrypting data at rest or during transit to the broker. Another common alternative is leveraging HTTPS over TLS to protect communication channels. However, these require the producer and consumer to share a key, and that is used for encryption and decryption, obviously. So appropriate key management need to be considered as well. Make microservices architecture secure by design. What do I mean by that? So microservices are a small autonomous unit that address individual functions and work with other components of an application. So operating these distributed components bring its own unique set of security requirements, because instead of a single entry point, microservices offer dozens or even hundreds of potential vulnerability points. With microservices architecture, being secure by design means keeping security top of your mind in every single stage of the software development lifecycle. So testing can be built into the delivery pipeline to help minimize the manual security checks that at the end could easily overwhelm your security DevOps team. Next, more of these best practices include things like scan for library dependencies. Perform code review on third-party dependency is crucial because popular libraries and toolkits that developer uses today are often source of software vulnerabilities. As a good practice, we need to ensure code written by others is not making our system insecure, right? So organizations often mix public and private dependencies in the same code base, and so careful configurations of the repositories in the build process must be considered, since dependency confusion attacks can easily bypass your security controls. Managing third-party dependency is key on keeping your system secure. Another security mechanism that you can use is basically limiting or limit API rates. Rate limiting can help APIs from being overwhelmed by requests, thus preventing denial of service attacks. A basic defense against this threat is to apply rate limiting to all requests, ensuring that you never attempt to process more requests than your server can handle. API limits can be accomplished by implementing API throttling or request timeout. Throttling limits the number of requests to a service in a time span to prevent overuse of resources, while request timeout set the total time available for a request to process and be answered. Lastly, and very important, you need to closely monitor your systems. Even if you think that you are designing the best architecture and have a perfect CI/CD process in place, it's still very important to monitor your system, and it's crucially to do this continuously. So implement system event logging and monitoring could assist you to determine if unauthorized security-related activity has been attended or has been performed on your event-driven architecture. And it will allow you also to follow up investigations and remediations if it's necessary. So I have given you a quick overview of what is an event-driven, what are some of the benefits, how to protect event-driven by applying security best practices to that. But what is, the real value of this technology? So why we don't discuss on event-driven architectures, use cases that can help you to build some better security solutions in your organization. I would like to make a small disclaimer here. I have a couple of scenarios that I would like to share with you, and all of them has been built basically using AWS resources. With this, by no means you have to be forced to use AWS to build this, as these services are similar in any other cloud provider like Azure, GCP, Oracle, IBM. Obviously, each of them have different naming for their services, but the concept applied here, it will be applicable to any other cloud. And also, I would like to say that the scenarios that I present in here are a high-level scenarios without going into too much of the technicality of each service or the communication protocol or the security behind each of these layers. It's just for the sake of most people understanding. I'll try to use something simple to explain and a high level. So let's explore the first scenario. So very common in any organizations today is password, secret, or key rotation. Everybody pretty much have that need for that. We know the limiting lifespan of a password reduces the risk and the effectiveness of password-based attack and persistent exploits. Today, password rotations are heavily dependent on manual password management. And the sheer number of credentials to rotate generally means that when we left these to humans, password best practices are not followed correctly. So these are some of the reasonings by looking at this. With EDAs or event-driven architectures, you could eliminate most of this headache associated with key and password rotation by automating end-to-end the management process. So in this diagram, we have different AWS services. Starting on the top with number one, we have a service called AWS Secret Manager. Secret Manager is basically a password vault. It's a place where you can securely store key passwords and secrets that are used by other systems to operate. Secret Manager also offers different features. And one of those features is the ability to schedule rotations on timely basis. So imagine you have passwords that are near to expire or actually expire, and by doing so, your system is now being disabled, right? Or you prevent someone to access the environment, right? So when a rotation event happens, we engage a service called AWS Lambda. And Lambda is a compute service that runs on your backend, on your backend code, sorry, in response to events. It could be written in different programming language such as Node, Java, C#, Python. This, I guess, this is code agnostic in this case. But focusing back on this, Secret Manager inform based on the rotation schedule that a password is about to expire. Using Lambda pushes that event into an AWS SNS topic. AWS SNS is a simple notification service that can allow multiple things to happen when an event reaches to a notification topic. But in this scenario, one, it send an alert to your monitoring team, your SOC or your operations team, and two, engage your ticketing system by opening and assigning a ticket to this event. At the same time, so there's a set of lambdas that are written to publish, rotate, generate, and change passwords or secrets or key. The lambda will engage AWS KMS or Key Management Service. Key Management Service allow you to auto-generate securely new keys and secrets. So that generate a new secret, it pushes that back to the secret managers, rotate the old secret with the new secret, and at the same time, another task that is written on the Lambda will allow us to change the credential on the affected endpoint. In this case, we're using AWS EC2. It could be a server, it could be a workstation, a VM, where the password need to be changed, or the secret, or the key. Scenario number two, another very common use case, is security data enrichment. Very important for today's security operation. As more information is available to our SOC team, the better they can address an incident and respond appropriately. So threat intel enrichment is critical component of any incident or threat investigation process. The enrichment process helps to remove false positives and gather actionable intel for threat response and security operations. In our current security landscape, hundreds, if not thousands, of indicators are collected daily. And these are generated by most of your security tools that you currently have. Leveraging event-driven architecture could allow security data to be automatically enriched with more detail and context to improve your incident investigation. So again, another scenario using AWS. Indicators of compromised files can be uploaded manually or automatically by any system integrations with, in this case, we're using S3 bucket, which is basically a storage container. Those are uploaded here, and as soon as they reach out the bucket, we have a Lambda that is written to retrieve the deltas of that IOC information, produce a message, and send a message to a queue using Amazon SQS or simple queries, simple queues service. Then we have another Lambda that is executed by this event when something reach out SQS to consume the message and update my backend database. This is the database that fulfill my SIEM. In this case, I'm using Elasticsearch as a service for my security incident event monitoring or management. When my security team need to retrieve or run a query to find information that would be useful for an investigation, they basically engage REST APIs over HTTP or over HTTPS that will connect to an Amazon API gateway for get, post, or delete. These are basically the commands that the Elasticsearch allow. Either you get the information, you post new information, or you delete a record. That engage with a third Lambda that allows us to run this or to perform this operation. And the information obviously stored in the database. All of this is serverless. There's no infrastructure required for this. All of this run on AWS Fabric, microservices communicating over secure protocols and channels. No infrastructure needed. So cost is only associated to the time you use or engage those services. No human interaction here, unless you decide to manually upload the files into the S3 bucket. On scenario 3, we talk another very common use case, virtual machine management. Right? VM management is extremely critical within modern businesses because poorly maintained endpoints are the main reason to successful breach. Automated endpoint security help organizations to prioritize updates, patches, as well as deliver cohesive security services, update applications, and so forth. With the rise of people bringing their devices to work, it is challenging for IT security teams to protect endpoints in a scalable way. Event-driven architecture basically enable you to automate routinary IT processes, such as applications update, patch management, and auto-remediate security incidents. Everybody needs this. In this scenario again, AWS offer different security services. In this, I'm displaying just a few of them, but each one of these produces alerts or findings or events. We have listed here Security Hub, Amazon Guard Duty, Inspector, and Cognito. So when one of these events are produced, they're configured to push such events into Amazon CloudWatch. And Amazon CloudWatch is basically a monitoring service that collects logs, metrics, and events. When those events are reaching Amazon CloudWatch, we pushes those into a topic in SNS, similar to the previous example. You inform your security team and you engage your ticketing system at the same time. Then we have a Lambda written to flash security events. When new events reaches SNS, the Lambda will flash them and run commands against AWS System Manager. AWS System Manager is a service that allows you to securely manage your infrastructure in AWS Cloud. That will allow you things like update, patching, application control, and even incident and access identity and access management, or changing credentials in an endpoint. In here, we have displayed a cluster of VMs where it could be hundreds to thousands of different machines. Those machines can be living in AWS or anywhere else. The system manager basically have the ability to update, patch, and apply controls on these as an event that is produced by a security service is produced on the other end. Or another example of serverless, where there's no need of infrastructure other than obviously the consumers in this case, which are the EC2 or the VMs, but any of the other services are microservices running in AWS Cloud. And finally, my last example here is the scenario where everybody has to comply with some kind of policy or governance. So we have policy compliance management and continue policy monitoring, identify violations at early stage, and allow better response life cycle. Another reason for using this is to reduce compliance time from days to minutes by using events to trigger remediation tasks and suggested actions. Policy lifecycle management automate consistent approval review process for up-to-date policy compliance. And event-driven architectures allow admins to resolve issues before they become an audit finding. That's the end goal, right? You want to remediate things before it reach out to your audits. This can be done in real time, and it definitely will help to enhance your compliance posture. In this scenario, we explore cloud resources. Cloud resources could be anything from storage, data, compute, network, or security. They're all being monitored by a service called AWS Config. AWS Config is a service that allows you to check for and validate compliance posture of different resources on the cloud. When a policy is non-compliant, when one of the resources fail to comply on policy, those events are pushed to CloudWatch. And again, as similar as the previous scenarios, you have different ways to alert your security operations and your IT teams by opening a ticket. But when here in number 2, when a policy is non-compliant, 2 things happen basically in parallel. 1, pushes the event to CloudWatch for further notification. And 2, it could trigger a remediation task, basically engaging a Lambda function. The Lambda function will have some code written to remediate any findings identified by AWS Config and push those remediation tasks into the cloud resource to fix it. This is a perfect scenario where something is identified, non-compliant, and pretty much auto remediate. There's other steps that you can take in the middle, where you probably want to have some kind of change control process in place for approval before the change happens. But all of these can be automated and written in code, basically leveraging AWS Lambda and functions. All right, Joe. With that, I reach out to the end of my presentation. I hope this has been informative and you guys have enjoyed it.
Thank you, Jose. It has been very informative, thank you. And I'll share with you that I have one healthcare customer who is currently sort of in the middle of the first scenario of the secret key rotation that you brought up. So very timely. And for those attending, I think you probably have seen Jose demonstrating great skill and expertise in this area. And as I mentioned sort of in the beginning, that's where we can, yeah, it's okay, Jose, you can move forward. That's where our vCISO services come in. For an example, you can leverage this highly skilled team to help you define, plan, anything around policy, the topic today, whatever it may be. So please reach out to your rep or to the contact information at the end of this presentation. Specifically for today, we are offering to those in attendance, we can have a complimentary half-hour meeting, a whiteboard session type of conversation around the topics that we discussed today. Again, really the goal here is to have yourself and perhaps Jose or others talk about these at a high level and see what's appropriate for your organization. So on the post-event survey, you'll see an opportunity where you can select that meeting to happen. With that, Jose, I think we've reached the end. I don't have any questions today, but certainly, folks, if you advance to the next slide, Jose, you'll see some contact info. You can certainly reach out to that email address if you have any questions. We look forward to engaging with you on these. And with that, Jose, once again, thank you so much. And for everyone attending today, thank you for taking the time. And we hope to see you at a future presentation. Thank you very much.
Thank you, everyone. Have a wonderful day.